And that was the third time that I watched my entire stock portfolio go from 7 figures down to 3. And it's heartbreaking when it happens, but c'est la vie, right? Okay, so welcome to Physics, everybody. It is Thursday, August 22nd, and we get to do a little bit of math today. Now, you guys all get your computers at some point today, is my understanding, so long as you have your forms and such signed. But right now, you will likely need a calculator for today. There should be one in your desk. We don't need it right this second, but within the next 10 minutes or 15 minutes, we will. Now, what is the base unit that we're going to use for length? A meter. What if I have 1,000 of them? A kilometer or a kilometer. What if I have 1,000,000 of them bad boys? 1,000,000 meters. It's okay. A megameter. What if I have 1/100th of a meter? A centi. Now, what about 1/1000th? Milli. And what about 1/1,000,000th, which would be 10 to the negative 6? A micro. And I'll clear up. I didn't remember to Google the symbol. I'm pretty sure that it's mu or nu, but I'll double check that for you guys. Okay. Do you have at least the few that we talked about yesterday? These like 6 in your notes or accessible. Okay, there's a larger list available online. You can go way bigger than these, but those are the ones that we're going to care the very most about. Okay, 10 to the 9, just out of curiosity, that'd be a giga, not Chad, but more like a prefix for stuff. What's 10 to the 9? What number is that? 1 followed by 9 zeros is? A billion. Cool. Tera is 10 to the 12. Capital T for tera or for trillion. What's after a trillion? I heard it. Quadrillion. Cool. All right. So beyond that, we are going to start looking at dimensional analysis, and I will do as many example problems as we need. In here, as we're looking, the very most important thing that I want us to remember in here, and this is going to be a mathy statement. I'm going to write in this lovely purple or pink. Okay, yeah, that's the one. I'm not colorblind, but I'm not good with color. I'm going to write one more thing in red right now. Underneath your notes, it is entirely up to you, but this is going to be a math statement. Is there a number that I can multiply by without changing something? So like 5 times something must give me 5. 1. Are there other numbers that do the same thing? And that can be an ambiguous question. Yes or no would be okay. You said yes. What's your gut tell you? Yeah, 5 times, maybe not just 1. Okay, so, and that's okay. There's, depending on how you view it. What I want us to be really, really, really comfortable with is we will multiply, and I'm going to use mult for multiply, by a clever choice of 1 to convert units. Now, when we look at a clever choice of 1 to convert units, it can show up in a bunch of different ways. And if you guys remember seeing radians in Algebra 2, radians, they're a really weird version of a clever choice of 1, but they do happen. I can write the number 1 like this. I can just write 1. Can somebody give me another way to write it? And I'm actually going to make this an EG because it looks like everybody's talking. You know what? Yeah, we'll do EG. This is just like an example, right? Exempli gratia. Okay, EG, 1. That's the number 1. Give me another way that I can write 1. Without spelling it, because I'm not going to use words. That's silly. Oh my, 2 over 2. Okay, 2 over 2. Others? You will not be wrong. Pick literally anything you want. A over A is kind of just a general case to say it's there. And I'm just going to say equals, and we're going to use these ellipses to say this list never stops. This is non-exhaustive. Anything over itself is 1, right? Now, where we're going to see this gets a little wonky, and we won't do it today, but if we ever have to convert between customary and metric units, I'll show one more example. I shouldn't have done the ... yet, but I'm already committed. If you're measuring in customary, you're all probably 5 feet, I think. And what's the other value you give me? Or 6 feet, sorry. 5 or 6 feet, and then you add something else onto it. Inches. So if I wanted to write a clever choice of 1, maybe I have like 7 inches. 8 inches, 9, 2, 3, doesn't matter, whatever number you want to pick. I have inches there. Now, if I wrote 7 inches divided by 7 inches, that would be a choice of 1, right? Because it's something divided by itself. Is there another distance that may be equal to the same length, though? You don't have the number locked in, but is there some number of centimeters that's 1 inch? Anybody know it? And that's okay. So check this. This is where it starts to look really wonky. 7 inches over 2.54. And I'm going to say times 7 because I don't have that number off the top of my head. Centimeters. Those are the same distance. 2.54 times 7, whatever number that is the same length as 7 inches, and you can convert like this where the units don't match. You might have seen this, and you should have seen this in Algebra 2 when you were doing trig stuff. Half a circle is how many degrees? 180. Harder question. Half a circle is how many radians? Pi radians. So back when you were converting between degrees and radians, if that's something you did in Algebra 2, I'm not sure, probably at least a little bit, you likely chose to multiply by pi over 180 degrees or 180 degrees over pi. And that was just another clever choice of 1. We're going to make use of that fact like all the time, today especially, to make sure that we get this. Okay. The other part that we need to worry about, so this was all optional, right? Like, looked like everybody wrote it. I'm going to switch back to this lovely pink, we decided? Or you decided? I'll just go with whatever. Okay, other little thing, and this, not going to lie, in my opinion, is one of the driest things that we're going to talk about, like, this year. It's not my most exciting thing, but we're going to define it, and we're going to try to go fast. If I'm going too fast, let me know. It takes some practice. We need to talk about significant figures. Significant. There we go. Significant figures. You may see significant digits, as it's sometimes presented that way. I'm lazy with my writing. I would like to never write this again. You will see me commonly refer to this as sig figs, because I think that covers the same idea. Significant figures, or digits. Have you guys, do you recognize that word? Significant figures or significant digits. Okay, now for this, there is an immediate issue that we have. If I'm looking at this side of this yardstick or meter stick, this is really, you'll see this is the customary units, right? If I asked you to estimate something, the customary system works kind of funny because it's all based on 1 over some power of 2. So it's pretty easy to find a half an inch or a quarter inch or an eighth of an inch or a 16th or 32nd. Probably not a 32nd on this one, but it's cut into those pieces. If you were to estimate that some distance was 25 and a little bit more than a half, but less than 5/8, you have to kind of guess at that, right? So I'd have to say, just as a decimal, I'll say maybe it's 25.54. That's a guess at that point, right? Maybe an educated guess, but a guess nonetheless. I cannot actually record a measurement that's more specific than the device that I'm using. So if I have a timer that only does full seconds, not hundredths, and I try to time something, I'm only going to get it's 2 seconds or 3 seconds or 4 seconds, right? I would not be able to accurately and realistically say it was 2.5 because it doesn't measure in that situation. You have to pay attention to that, how precise our measurements actually are. So for these, quick definition, and then we look at some specific scenarios and we'll start kicking through them. So we will define significant figures as the valid measurement based on instruments or data provided. The best, and I'm going to sneak that in there, the best measurement based on the device or given information. And I'm going to shorthand information as info. Now, This is going to seem like kind of complicated, and like there's nothing crazy about the math, but there's lots of little rules. I want you to know right now, we need to talk about it. We'll try our best to use it, but I'm not going to burn anybody in here for if you get goofed up on significant digits with stuff. Like, we need to know about it so we see what measurements actually mean, but there's a few different cases that we will deal with. The first little subsection that I want us to look at is zeros, because lots of numbers wind up having zeros. So this is going to drive some of you crazy, I think. How's zeros spelled? Zero is Z-E-R-O. If I want it to be plural, how do you write it? Is it O-S? Okay, could be. Or it could be this. That one makes more sense for me, but I'm not great with grammar and stuff. I'm a pretty good speller. Either one is fine. You'll see me alternate between them because I don't know which one I really and truly like more. That's how I would spell it if I were the first person to spell it. Now, in numbers, especially the data that we're going to get, I'm going to use asterisks for all these because dashes are going to look like negative signs, and I'm going to avoid that. So, first and foremost, we have some zeros that show up as leading zeros. Leading zeros. And I'm hopefully going to be concise with this stuff. Now, all a leading zero is simply means it's before the first non-zero digit. So we'll just say here, before first non-zero digit. So these are so easy because every number ever could be written with however many leading zeros you want. Consider the number 2. Could I write it's the number 02? Or 002, or 0002, or 000000002? Like, all of those are the same number, right? In that situation, leading zeros that occur before the first non-zero digit are not significant. Okay. First rule, then there's going to be several little pieces that we need to look at with leading zeros. So, 2 different situations here. We're just going to sneak in EGs underneath. If we look at the number 0.035, which is a fairly precise measurement, how many significant digits, based on the only rule that we have at this point, would you say that has? Totally gave me a good idea. What do you guys think? Hold up a number. It could be 4, 3, 2, 1, or 0. What do you guys think? What's your gut say? How many significant figures there? So I've seen 1, I've seen 3, I've seen 4, I've seen 2. Looking at it, do I have zeros that show up before the first non-zero number? How many zeros show up before that first 3? 2. They show up before it. Are they significant? What do we say about leading zeros? Any that show up before that first non-zero digit are not, right? That thing has 2 significant digits. Okay. 2 sig figs. Now, in this situation, all you have to worry about is if the number starts with zeros, no matter how far it goes, we only count the ones that show up after. Okay, beyond that, if you have zeros that lead in front of a number, you could also have zeros that follow after the end of a number, which happens from time to time. So we'll have leading zeros that we have to concern ourselves with, but we'll also have trailing zeros. Now, in this situation, they just come after the number, right? So there's 2 situations that we have to worry about with these. And if we get to a point, my hope is only like 5 or 10 minutes total here, but if this gets like super dry and we need a quick break, let me know. We'll do something random. But trailing zeros, 2 situations that we have to deal with. If after the decimal, they are significant. And I'm just going to use sig as a shorthand for significant. So, for example, if we look at a trailing zero that has a decimal, something like 13.200, do we have trailing zeros on that number that come at the very end of my list? are they on the other side of a decimal? So in that situation, if we count the significant digits, 1, 3, 2, and those 2 zeros also count, how many significant digits here? What do you think? Sean, how many numbers are there that aren't zeros that are trailing in front of everything? So both. How many total numbers? How many trailing zeros? Do they come after the decimal? So they're significant. It's 5 numbers. This thing has 5 significant digits. Or figures. Okay. Now, the other alternative, though, is they don't come afterward. So we're just say without decimal. And I'm going to introduce a Holloway shorthand to you guys. It's fairly common that I've seen other people do, but it's not super formal. The word with shows up all the time. Do you guys have a shorthand for with? W/. Yep, that's super common. So I'm going to say that just so we have it, without. That's how I do it. Okay, if we have without a decimal, which there's lots of, like it's easy to think of large numbers specifically that don't have it. Without a decimal, they're not significant. So we're going to take a completely different number. Let's say 7,000. That is a 4-digit number. We can count them all. I have how many trailing zeros in this situation? 3 of them. Now, there's no decimal included in this number. So without the decimal, we don't count them as significant. Are there any numbers that do matter there, you think? You're right. I think I heard somebody say it. Somebody said the 7, like that's the only other option, right? The 7 is the only significant figure here. So if we look at that, how many total significant figures here? The 7 is significant, the zeros are not. 1. And it probably doesn't feel, I'm going to write the word 1 so I don't confuse it. It probably doesn't feel like super great as we're doing this the first time, and it's odd. I agree. This is the least fun thing that happens in all of physics, in my opinion. Okay. Now, beyond that, if, however, I'm going to throw just a example underneath, really small. I want you to talk with your neighbors with conviction, come to a decision, whether you're right or wrong, I don't care, but sound confident with it. What do I have the number 24,017 with a decimal at the end? And then we'll do 0, 0 as well. We'll just make it super crazy. I want you guys to, with your neighbors, it's going to take like 10 seconds. How many significant figures do you think are here? Which numbers there matter? Feel free to use muscles within your body to pull air into your lungs and then shape the air that you're exhaling with your tongue and vocal cords. Communicate ideas if you would like to. I've heard 5. Somebody else probably has 5. Other numbers, or everybody agree that it's 5 right now? If you think it's 5, that's fine. We'll talk about it here in a second. What other number might we get, though? Somebody doesn't agree that it's 5, and that's okay that you don't agree. What's the other option? 5 or 7, right? Now, if we look at it, and again, tedious, but let's check. Are there leading zeros? Nope, none in front. I could have had infinitely many. I don't care about them. Okay, are there trailing zeros? Do they happen after or before a decimal? So trailing just means at the tail. We do have them, right? We have trailing zeros. There's 2 of them. Now, if there's a decimal, they're significant. There is a decimal there. So we have 5 whole digits, right? Those 24,017. And in this case, the 0.00 indicates to me that whatever device we're measuring this with has the ability to measure to the nearest hundredth. So we would count those as significant. This has 7. Sig fig. Okay. Now, other options that exist, any non-zero digit is significant. So that'll be the last little part, and this is going to look stupid in the notes, and I lied. I'm just going to take this whole thing, and we're going to move it up top. So we'll keep going, because I don't want it to be on its own page. Okay, so here's everything that we've done so far, all of that information, and a couple more comments just to hopefully organize these in a nice fashion. Any non-zero digit is significant, always. Any non-zero is significant. And we have a couple easy little statements to make, and then we have to talk just basically at the very beginning level of what does it look like when we're actually doing operations, because that's going to be our goal today. So, any non-zero is significant, and beyond that, anytime that you get a zero between digits. So, for example, we had this 24017. Zeros between digits are also significant. Okay, so we have those guys knocked out. Have you all used scientific notation at some point in your lives? So instead of saying 7 billion and 5, you might say 7.000005 times 10 to the 9. And maybe you have, maybe you haven't. If you are comfortable with it at this point in time, that is an easy way for you to determine how many significant figures there are. Because whatever you're going to multiply by 10 to the whatever is the number of significant digits that you have. Okay, now in here, unfortunately, we are bound by the limit of your mathematical knowledge. We only do arithmetic in here. We don't do anything super crazy, which means not only do we have to know where significant figures are, but we have to be able to do operations with significant figures. Okay, when you hear arithmetic, that's like the old school way to talk about math. There's only 4 operations that I would consider truly as arithmetic. Can you name one of them, the 4 most basic? If you have a 4-function calculator, what shows up on that calculator? Add, addition, okay? Anything else? Subtraction, cool. Multiplication, and division. So another small side step. Order of operations stuff you have all seen. What word do you use for order of operations? Everybody uses PEMDAS in here? Have you heard GEMS before? Okay. PEMDAS, what's weird about it and why I like GEMS much more is because addition and subtraction, they're really and truly the same thing. Subtraction is just adding a negative number. So addition and subtraction on the same level. Multiplication is just the same as what other operation? Division. They're the exact same operation, which means when we hit these, we only have to worry about 2 specific cases. So for our operations, let's do addition first. And if you want, you can write addition and subtraction, but subtraction is just fancy addition. So it's not necessary. I will write it just in case. It is not required. Okay. The rules are easy for significant figures. If you are adding and subtracting, the simple rule that we need to follow is you're simply going to round your numbers, round result, to the value that has the least significant figures. Okay, that's all. Adding and subtracting, just find the one that's the smallest and just use that piece of cake. Quick example, and I'm not going to try to make it too crazy, but in this example, I want us to do the following calculation, and I'm not going to write it down because it's going to be wordier, but I want us to identify the number of significant figures and then do the calculation itself and identify the number of significant figures. So for this, let's say we have a number like 4.56, and we're going to add to this, I don't know, let's say 3.2. Okay, and I will switch colors to show that that's where we started, and we'll get our answer out of it. So on these, let's just make sure that we are looking at this. How many sig figs does 4.56 have? 3. Okay, so there's 3 here. And of these 3, there's 3, and we're going to take one little expansion on that. How about after the decimal? With 2 after, and I'm just going to say 2 after, and we know we're talking about the decimal. Okay, I agree with that. There's 3 and 2 after the decimal. How about the second number? How many significant figures? 2 of them total. It's 3 and 2, right? There's 2 here. How about after the decimal? 1 after. Now, there's a super important word that I need to sneak in here. Round the result to the value that has the least significant figures post-decimal. And that's my bad. I was excited to do a little bit of math rather than just writing words. Sorry. Okay. As we look at those numbers, can we agree that 3.2 has the least number of significant digits after the decimal? So our answer should have how many after we combine them? So we round the result to the value that has the least significant figures post-decimal. One of our numbers has 2 after the decimal. One of them has 1 after the decimal. Which one's smaller? 1. So our answer should have 1. Now, looking at this, as we go through this, I don't mind if we take this step. If you, like, let's say for whatever reason, this was on like an actual test you're taking. What's 4 plus 3? What's 56 plus 20? Or 0.56 plus 0.2? 76? Okay, this answer, if that's what you gave me, and this is what I want to highlight, this is not really correct, but I'm not going to destroy you for it. Like, that answer is mathematically correct, right? Now, if we're really relying on measurement devices, which happens a lot in physics, when we adjust this, how should I write this number as my final answer? 7.8, and you've got it. What's the rule for rounding? How do you know if it goes up or down? 5 or bigger. Okay. Is that okay? Do we need to do another addition? Okay, so we've knocked out literally half of all the operations that you might have to do in here. If we have addition and subtraction, then it makes sense that we also have multiplication, which I'm going to use a Holloway Molten. So Acacia is the apostrophe, and division, div apostrophe n. Okay. When we go through multiplication and division, nothing crazy. We're just going to say the result. The result has as many sig figs as the value with the least. Now, only a little tiny change here. Addition and subtraction, you follow the decimal. Like, I don't really care about how many total significant figures there are in each number. After the decimal is what matters when you're adding and subtracting with significant figures. Here, there's no reference to the decimal. And it's not that I just forgot it because I'm excited about the math this time. There really is no concern with it. So we'll do one of these, and you probably want to use a calculator while we do this. But let's look at one. I want, rather than me just talking about it, I want you to do the exact same thing, but you don't have to worry about the after the decimal part. We want to multiply 2 numbers. 4.56 times, and I would advise nobody ever use x for multiplying here. I'm going to use parentheses or the dot for multiplying. Let's do 4.56 times, I don't know, 1.4. Okay, underneath, and it's going to be tedious, you will not have to do this on a regular basis. Identify the number of significant figures here and here, then grab your calculator, get your result, and then make it have the correct number of significant figures. I'm going to give you guys a minute. I'm going to walk around aimlessly, make sure I get my daily steps in. Cool. When we go through, there's 3 significant, what is going on here? Quit it. Okay, 3 there, 2 there. Can you guys identify which of those is a smaller number? It is indeed 2. So what's the actual answer on the calculator give you? 6.384, which has how many? Uh-oh. Why uh-oh? Not really uh-oh, but in the world of significant figures, uh-oh.
Oh, it's 384.
Oh, thank you. So that was a good uh-oh. Not the one I was after, but good catch. Okay. You guys second that number? I think this is too many. This is not how our answer will look. Why? It needs to have 2. So what's our answer? 6.4. It's super annoying sometimes. Like, that bothers me as a mathematician, but it's the slight distinction between math and physics, right? Like, they're obviously the same. We can get a more annoying case pretty easily. If I wanted to take 4.56 times 10,000, 10,000 without a decimal only has one significant figure, so you would get an answer of 4,000 when you or 40,000, which is super annoying, but it happens. I will not burn you on this, but we do have to make sure that if anybody in here ever pursues a degree or focuses on these sorts of things, this is what we have to make sure we have. Okay. Scientific notation will help. Should we do some math problems that use all this stuff? Yes, I love the excitement that I can feel. It's electric. Okay. Before I move on, anybody need more time to write it, or are you good? Okie dokie. This screen's just getting erased. Okay. We have a few examples. And we're going to start off with just a wordy one because I want to demonstrate solving problems. So let's do a little section. It's all going to be examples, but I want to make sure we have an agreed upon, like, at least starting point. Physics work and math work obviously going to be very similar the way it looks, but we're going to get into some pretty complicated problems eventually. Not today, I hope. But as we're solving problems, I want to make sure that we're all following the same kind of template for solving them and setting them up and showing work. Because if you start a problem wrong and spend 20 minutes doing it, it sucks if you have to restart from the very beginning because you were wrong then. Okay, so we're going to jump right in with one. Here we go on our example for solving problems. We'll do example, and we'll just set this up. I'm going to use a little editing magic. When a car travels 434 kilometers in 4.5 hours, what is the average speed? And fairly confident that most of you, if not all, could probably just grab your calculator and answer the problem right now. Maybe. When you talk about speed, we haven't said anything about it yet this year, except for right now. You guys typically measure speed on the road. What's the speed limit out here? 30 what? Okay, 30 miles per hour. When you see the word per showing up, what does that tell you operation-wise is happening? Say it again? Each one. So how about as an arithmetic operation? Does per mean that it's going to wind up adding or subtracting or multiplying or dividing? So careful. If I say I make $5 per hour and I want to say I worked 10 hours, I would just multiply 5 times hours? Or how does that? Not quite. The word per, I'm just going to give it to you, typically means divide. 30 miles per 1 hour is the rate at which you're traveling. So the word per, divide. We're going to use the heck out of that, and it's why we talked about the fractions. So when we're setting up physics problems, and I'm going to be crazy about it, tests and stuff will have places for you to put this, I want us to make sure that we always model the following. Every single time, we want to write what is it that we know, or our known information. You could say given if you would rather. It makes it feel like a proof. We are not proving stuff, but the word given is just as good. What do we know about this problem already? Okay, so what sort of thing would that be? I traveled that far. What's a word that might represent how far I've gone? Length would work. Could I use distance in this context as well? Okay, so I'm going to say distance, which I'm just going to use D for distance, is equal to, you're absolutely right, 434. Now, if I stop here, I hate it. I hate everything about it. Why? Because why? I'm not specific. I better make sure that we know that the label game and the unit game might wind up happening. Anything else that we know? Okay, and what would you call that one? That's time. So I'm going to use a lowercase t for time, 4.5 hours. Now, that's it. That's all the known information that we have. We are asked to find what? Okay, so we're not worrying. There's nothing crazy that has to happen. We're just going to call it speed right now. Now, we'll talk specifically about average versus at some instant in time. What letter might we use for speed? I'm fine with S right now. Speed S, and that's what we're after. I don't know what it is yet. I'm just going to put a question mark. Okay, I want you to be able to identify the known information, what it is that you're actually supposed to find, and then this one I count as its own little thing, but equation and math. And EQN is my shorthand for equation. So, this one, I'm just like, we haven't talked about it. It's okay, you may not remember it. Is there a way to relate distance, speed, and time? You guys, we talked about it a second ago. If I ask you for the speed outside on this road, what is it again? It's 30, what was that other unit that we needed though? Say it again? Like, what's the speed limit out here is the only question I had. 30 what? Miles per hour. Now, notice, when we say 30 miles per hour, which is what we just used, right, MPH, what it really is miles, 30 miles divided by 1 hour. It just is, like, awful to say that every single time. So when we're looking at that, speed is equal to 30 miles, which is a measure of what? Distance, divided by 1 hour, which is a measure of time. So that there gives us everything we need. Speed S is exactly equal to your distance D that you travel, divided by the time T that it takes you. Okay, so looking at this, we're trying to find for speed, which I've already solved for. Do we have values for distance D and time T? Do we know those values in our problem? Plug and chug. That's all we do. Now, this one, I'm going to make a step one little further. What's the distance we travel? So check it out, 434 kilometers. Being mindful that our fractions aren't terrible. Divided by, what's the time that we travel for? 4.5 hours. And then here's my challenge for you. Right now, if I just look at the units, do I wind up in kilometers per hour? You say no, Sean. Why? So, say that again, sorry. So hours is time, but what's that kilometers? It's up top. And what's another word that we might see like regularly for division? Louder. Per. Do I have kilometers divided by hours? In my expression, I can see it, right? That is literally kilometers per hour. Is that a way you would talk about speed? Instead of miles per hour, would it be okay to call it kilometers per hour? Yeah, if you're in the metric world or anywhere but the US realistically. Okay, extra challenge. I want you guys to get my answer. Like, it's a quick calculator thing with a little bit of additional thought. So whenever you get this number, shout it out, and then we'll just see that somebody seconds it. .4 is like exactly 0.4? 96.4 repeating? Okay, I'm going to do 4 repeating. And here, I've kind of lied to you earlier. I don't care if you do your units like this once you're like at your final answer, but it's just not conducive to doing the work. I'm not right. I'm wrong. Something is overlooked. I will not burn you on it, but I don't like that answer. Why? Love it. We are multiplying or dividing. I have two numbers given. 434 has 3 significant figures. 4.5 has 2. If we're multiplying and dividing, we better have 2 significant figures in the end. This answer, again, I won't count you wrong for it, but we should try to be mindful. This is just 96 kilometers per hour. Or if you'd rather, this one, for whatever reason, annoys me, 96 kilometers per every 1 hour is what our answer really reads. But nobody writes it that way because why would you put a 1 in the denominator? All right, one small extension for us. And before we do the extension, give me a scale. 5 says, all right, that's so easy. I'm good with it. I don't need more of these. 0 says, I hate it, I don't know how to do this, I could not do it on my own, or anywhere in between. 5 says I'm good, 0 says nope, and anywhere in between. Some sort of indication for me. 5, 0, 1, 2, 3, 4. Okay, so looking at this, one more extension that we're going to look through. Kilometers per hour makes sense if you're talking about a vehicle. Like, for sure, it does. I want to expand, though, and we're going to do a second part of this problem. So I'll try to keep in line. Now, I want us to find this 96 kilometers per hour. What 96 kilometers per hour is in, more commonly, kilometers per hour is large. That's like vehicles. If I were to like shoot a small projectile and try to measure its speed in this classroom especially, kilometers per hour won't be the number that makes sense, especially if we want to measure it. What are our base units that we're going to use? Meters per, boom. I want us to convert this to meters per second. And right off the bat, you guys trying it yourselves, or are we trying it as a class and making sure that we're all cool with it first before trying it? Okay, lots of strong opinions on that. Do y'all like to struggle? I like to struggle with stuff because it makes the eventual conclusion more satisfying. That's like one of the things I really like about math. But I get it if you don't. We'll do this one together. Okay, so we are just converting now, and luckily we don't have to go between any wonky units. Let's knock it out. First off, this fraction, good or bad? The way that I've written this fraction, it is the worst. Let's change it. What goes in the numerator at the top? 96 kilometers. So here we are, 96 kilometers over, and this part always feels silly. When I don't write it, I don't say the number, but how many hours? Per 1 hour. Okay. Our goal is to convert this to meters per second. And the good news is that we only have to multiply by 1 over and over and over. Now, oftentimes you guys will be able to calculate through this. The unit game and showing all this work ensures that we do the right thing. There is not a right choice for this first piece, but we need to change two things around. We need to change kilometers into meters, and we need to change hours into seconds. Now, we're going to do this in a set of 2 or 3, depending on your guys' input, different choices of 1. What do you want to change first? Hours to seconds or kilometers to meters? There's not a right answer. I don't care which one we do first. Kilometers to meters. Now, the good news is that when things divide out, if I have kilometers over kilometers in a fraction, they would just fall out, right? You might say cancel. I hate that word. They divide out or they one out. But if I had kilometers in the denominator in my multiplication, that unit would be gone, right? So there must be a way to convert somehow so that I can make kilometers in a moment divide out. And I want to be left with what up in the numerator? What am I trying to get to? Meters. Okay, so I've already crossed them out to show that they will divide through or cancel, if you will. If only there were a conversion of some number of meters is some number of kilometers. 1,000 meters is the same distance as how many kilometers? 1. That looks like I'm multiplying by 1,000, but I'm not. The units that we've adjusted make it so I'm multiplying by a clever choice of what? 1. Okay, if I were to carry this calculation out and type it in right now, I would be in miles per, what's the other unit that's left? I'd have miles in the numerator, and what would be in the denominator? So if we multiplied straight through, this would be 96,000 meters divided by 1 hour, and then just 1. What's 1 hour times 1 going to give me? 1 hour, right? I don't want it to be in meters per hour, though. So I typically do this in one step. Let's check it out. I want which unit to fall out? I'm trying to get rid of hours, and I want it to turn into what? Okay, so this one, hours has to go in the numerator because I need them to divide out, 1 at the top, 1 down low, and I need seconds down here. We now just need to simply find our choice of 1 here. Do you know any, or are you able to find how many hours and seconds are the same amount of time? Okay, so what's 6 times 6? Add 2 zeros. So for every 1 hour, there must be how many seconds? 3,600 seconds. Now, in this calculation, notice what happens. I have an hours in the denominator that as we multiply through is going to divide out with an hours in the numerator. When I look at this, what's the only unit anywhere in the top of my expression any longer? It's going to be meters in the numerator, and we'll get that number here in a second, over what's the only unit that I have anywhere in the denominator? Seconds. Is that what we're asked to get to? Without having to just type into my calculator, because the calculation itself isn't crazy, we have done the work to make sure that we get the right value. This winds up being, if we take one step without a calculator, 96,000 meters per every 3,600 seconds. Does that really make sense to use that number though? No. What should we do? Or rather, what do you get when you divide it? 2.6 repeating? Okay, I'll trust you. 2.6 repeating. How many significant figures since we're working through division here? This one has 2, this has 1, and this has 2. We're multiplying or dividing, so I just look at the one with the fewest. Which has the fewest? 1. So what should our answer actually be? Careful. 2.6. We round it to one single digit. About 3 meters per second. Now, 100% honesty, I like 2.6 a whole lot more than I like 3, and I'm not going to be crazy about it. That's the end of class. This evening, I want you to try some problems for me. 30 minutes max. I want you to attempt for me this evening. Homework 1.2, page 13. I want you to try 8 through 14. The Desmos app is your friend. If you don't have a calculator, I don't care. Like, if you keep your answers in fractions, but your sig fig stuff is going to be harder. All right, later Raiders, no more than 30 minutes tonight on this. I don't think it'll take that long. If you're struggling, I'm here before school, at lunch, and after school. Y'all have a wonderful day.